in this video we're going to take a look at discontinuities, right? So if a function is not continuous at C, right, so if it's not continuous at C, then we say that there is a discontinuity at C. We have two different types of discontinuities that could show up. So the first is a removable discontinuity. So you could have a discontinuity that is removable. A discontinuity that is removable, it looks like a hole in the graph. And we say it's removable because if we were to define the function, we could fill in that hole, right? And at that point in time, it would be continuous, right? So that's why it's removable. We could fill in that gap. Or we could have non-removable discontinuities. And when we have non-removable discontinuities, these things, they look like, they might look like a jump. So you could have a function value at that point, but there's this jump, so there's no way to remove, to fix that discontinuity. Or if you had something like this, where you have a vertical asymptote. Again, there's no way to remove that discontinuity. So whenever you have a jump or a vertical asymptote, something along those lines, that discontinuity is not going to be removable. So that those are the ideas of continuous and discontinuous. Let's look at some examples. Let's consider the continuity of the following functions. And so here we have the function f of x equals 1 over x minus 1. So where would you have issues with this function? What does this function look like? If we were to graph it, what does that look like? Well, at 1, there's a vertical asymptote. If we have values smaller than 1, we have this, and values larger than 1, you'll have something that looks like this. So what is the continuity of this, right? Where is it discontinuous? Well, it's discontinuous at x equals 1. Is that discontinuity removable or non-removable? Right? Is it possible to fix that discontinuity? Well, no. So that is a non-removable discontinuity. So where is it continuous? And so if it's a non-removable discontinuity at 1, that means, oh well, and we didn't identify any other discontinuities, then this is going to be continuous on the interval from -infinity up to, but not including 1, and then on the other side of 1, starting at 1 and going up to infinity. Right? This is our union. We are joining those two sets together, those two intervals together. So that is where it's continuous, and then it's discontinuous only at x is equal to 1. Let's look at the second example here. In the second example, something we might observe about it is that top part, it will factor. It will factor into x minus 3 times x minus 4 over x minus 3. Now you might be tempted here to cancel out the x minus 3. We can't do that here because that would cause the function to be very, very slightly different. And what would be different about it? Well, the difference would be our function here, this original function, it's not going to be defined when x is equal to 3. And when x is equal to 3, there's going to be, this function is going to be undefined. What does the picture of this function look like? Well, since that value right there at 3 would have canceled out, that tells us that there is going to be a hole, a removable discontinuity at x equals 3. You have a hole at x equals 3. Now, other than that, right, so that temptation to cancel those out, you could cancel it out as long as you said, now our function f of x is equal to x minus 4 as long as x is not 3. Right? So at 3, we need to have a hole in the graph, but otherwise this graph is going to look exactly like y equals x minus 4. And so we have a y-intercept of -4. At 3 here, we're going to have a hole in the graph. And so what does the function look like? What's the continuity of this function? Well, it's continuous on -infinity up to 3 along with 3 to infinity. Right, so at 3 we had that removable discontinuity. It was continuous everywhere else. Excellent. So those are some ideas of continuous and discontinuous. Let's look at 2 more examples and then we will close this video. All right, so let's look at some examples involving trig functions. Here we have f of x equals cosine x plus 1. So the cosine graph, it's a wave. This wave has been shifted up 1 unit. And so I'm going to have something that looks like this. Was there any discontinuity in that graph? Nope. This graph, this function, is continuous everywhere. So there's not anywhere that this is going to be problematic. What about tangent? The tangent graph, some of you might be thinking already, the tangent graph has some vertical asymptotes. And so, yeah, those vertical asymptotes are going to be problematic every time there's a vertical asymptote. That tangent graph is periodic with a period of pi. There's a vertical asymptote at pi over 2 and negative pi over 2. But wait, that's not it. We also have a vertical asymptote at 3 pi over 2 and 5 pi over 2. There is going to be a non-removable discontinuity when x is equal to an odd multiple of pi over 2. So we can write that as 2n plus 1 times pi over 2 for n being an integer. Everywhere else, it's continuous. So at each one of those vertical asymptotes, we're going to have problems. Other than that, we're going to be okay. Great. In our next video, we will look at even more examples. So come on back and look at some more examples.